Problem number 7. Doo-doo-doo. All right, let's do it. That was a really dramatic introduction. I'm happy. Okay, here we go. Let's determine Flipper's average. What is Flipper? I know. I think it's supposed to be a dolphin, but what if it's not? What if it's like a velociraptor, like a philosophical velociraptor, or a toaster? I'm gonna pretend Flipper is actually a toaster. So we're gonna determine Flipper's average velocity. Show your work. Okay, fine. Gosh, not to get all aggro about it. So here we go. When we say average velocity, again, this is just another term for the slope. Okay, so here we go. Let's just label these points. 6, 40, and then 0, 10. People really want to choose points that are next to each other. You don't have to do that. Just pick any 2 points where it crosses like a corner so you can actually see what you have there. So I will get the speed. I'm not going to use, and I'm going to use the rise over run formula, but I'm going to write it like this. Okay, I'm really going to write it like this. So this is going to be 40 minus 10 over 6 minus 0. So we're going to end up getting 5 meters per second when we do this. Okay? Now, it says write a mathematical model for the relationship between Flipper's position and time. This, again, is a way of saying write down the equation that describes the motion of the object. So we start with x equals v naught t plus x naught. This is the physics way of saying write the point slope equation for the line. But it isn't just an equation for a line. It's an equation that lets us know where the object's going to be, where Flipper the toaster is going to be at any point in time. So we write x equals, the slope is 5, so that's the speed, times the time plus its starting point, which is 10. So if we want to know where our mobile toaster will be at 8 seconds, we're actually going to plug in the number. So x equals 5 times 8 seconds for time plus 10. And that's how we're actually getting 50 meters as our answer. So that's problem number 7.